Hello class, today we're going to be going over imaginary numbers, so please turn to the appropriate page in your packet where we first get introduced to imaginary numbers. Imaginary numbers need to be given some kind of placement, otherwise you guys will think that we're just talking about made up things. So to give you a little bit of context, mathematicians for the longest time thought that negative numbers were not real numbers. Yet other mathematicians came along and said, well, we have to be able to solve an equation like this one. X plus 1 is equal to 0. What is x? X has to be a negative number. So similarly, there's other equations like this one. X squared plus 1 is equal to 0. Now if we rearrange the numbers a little bit, we get x squared is equal to negative 1. And so then what is x? X would then have to be the square root of negative 1. And this is where we begin with imaginary numbers, with the square root of negative 1. So the square root of negative 1 is going to be abbreviated from here on out just as I. I is kind of the imaginary unit. We use it to, whenever we talk about imaginary numbers, we use that as the unit to kind of give an idea of the scale of the imaginary number. But it's not the only imaginary number. There are many other pure imaginary numbers, like 5i, like 4i square root of 5, or the square root of any negative number. These will all be pure imaginary numbers. There are also complex numbers, which include both a real number component and an imaginary number component. So the following would be considered complex numbers. All right, 7 plus I, 2 plus 3i, 6 plus I times the square root of 7, or square root of 7 plus 5i square root of 13. In all four of these cases, the first term is a real number, and the second term is an imaginary number. But the number as a whole, so 7 plus I as a whole, is considered a complex number that has both a real number component and imaginary number component. But we're just going to be focusing on imaginary numbers in this class. So I'm going to talk about how we simplify negative square roots, but before we do that, a review on basic square roots will help us to reinforce concepts that we're going to need to use when simplifying negative square roots. Right? So let's look at the square root of 4. We know that the square root of 4 is going to be plus or minus 2. Basically, it's just 2. Now, if the square root of 4 is equal to 2, then we know that the square root of 4 times the square root of 4 is equal to 4. And that brings us to my first general point, which is just that the square root of any number times the square root of that same number is equal to that number. The square root of x times the square root of x is equal to x. Now we also know that x is equal to the square root of x squared. That's what I have in this rectangle here. The square root of x squared is also equal to x. Hence, that means that if we put these 2 points together, the square root of 9 times 9 is equal to the square root of 9 times the square root of 9. And this is going to bring me to my important second general point, all right, which is that the square root of x times y, all right, and remember x can be any number, y can be any number. The square root of x times y is just equal to the square root of x times the square root of y. And so, for example, square root of 45. Well, 45 is equal to 9 times 5, so that's the same as the square root of 9 times 5. And that is the same thing as the square root of 9 times the square root of 5. And so if we're simplifying the square root of 45, that's going to simplify to 3 times the square root of 5. All right, now using these points, let's start looking at how we can simplify negative square roots. So if we look at number 1 on your notes page, your first example problem, it's asking you to simplify the square root of negative 9. Now negative 9 is equal to negative 1 times 9. So it's the same thing as simplifying the square root of negative 1 times 9. Now, using my second general point, all right, that I boxed on the other side of the screen, we know that the square root of negative 1 times 9 is equal to the square root of negative 1 times the square root of 9. Now the square root of 9 is just 3. Square root of negative 1, remember we said that I means the square root of negative 1, and we use that as kind of our imaginary unit. So our final answer here is just going to be 3i. Let's look at number 6, and it might be really helpful to you to, at this point, pause the screen and see if you can solve number 6 in the exact same way that you solved number 1 before I give you the answer. So if you want to go ahead and do that, and then unpause and come back. Okay, so going through the same basic steps, we can break that into the square root of negative 1 times the square root of 192. That can be broken into the square root of negative 1 times 3 times 64. So it just so happens that 3 times 64 is equal to 192. Now using, again, that second general point, we can break this big radical into 3 smaller radicals. Square root of negative 1, which is just I, times the square root of 3, times the square root of 64. And the square root of 64 is 8. So our final answer, 8i square root of 3. I'm going to go ahead and give you guys the answers to 2 through 5 on the example problems. So the answer to number 2 is going to be 14i. The answer to number 3 is going to be I times the square root of 5. Answer to number 4 is 4i square root of 5. And the answer to number 5 is 4i square root of 2. So if you want to further check your ability to solve those problems, I've just given you those answers. And while this process is still fresh in your mind, go ahead and work on homework problems 1 through 7. So those are just 2 pages down. The first problem is the square root of negative 25. The second one is the square root of negative 324. So go ahead and keep this screen up so that it's showing you the steps that you need to use to solve those problems. And go ahead and just knock out homework problems 1 through 7. Alright, so I'm assuming that you have solved homework problems 1 through 7. So we're now going to go to that second or the third section of the notes that's titled Solving Equations. So the first example problem is number 7, x squared plus 81 is equal to 0. So the way we normally solve equations, we're going to try and isolate x squared. So we get x squared is equal to negative 81. We take the square root on both sides. That'll give us x is equal to the square root of negative 81. Now what's our next step going to be? Pause it and see if you can figure out what x is ultimately going to be equal to. Now the next step is we're going to break up the square root of negative 81 into the square root of negative 1 times the square root of 81. Square root of negative 1 is just I, and the square root of 81 is plus or minus 9. So our final answer, x is equal to plus or minus 9i. Let's look at number 9. And again, pause it, see if you can answer it before I give you the answer, and see if you can get it correct. Alright, I'm assuming that you've done that and that you're returning. So let's go ahead and try and isolate x squared. So we'll subtract 15 from both sides to get 4x squared is equal to negative 24. And then we divide both sides by 4 to get x squared is equal to negative 6. Take the square root on both sides. to get x is equal to the square root of negative 6. And the square root of negative 6 can be broken down into the square root of 6 times the square root of negative 1. And so our final answer is just going to be x is equal to plus or minus I times the square root of 6. All right, let's do one more of these example problems. All right, so 11, go ahead and try and solve that. All right, so what we're going to do is we're going to try to isolate x squared, and that's eventually just going to be x squared is equal to negative 147. Take the square root of both sides to get x is equal to the square root of negative 147. Now, if you might remember that neat little rule that if the sum of the digits of a number is divisible by 3, then so is that number. So our digits here are 1, 4, and 7. So if we add 1 to 4 to 7, we're going to get 12. 12 is divisible by 3, and therefore we know that 147 is divisible by 3. So if we divide 147 by 3, we actually get 49. So we can break up this the square root into the square root of 3 times the square root of 49 times the square root of negative 1. So what's our final answer going to be? It's just going to be plus or minus 7I times the square root of 3. Now, if you want to check your answers on the other example problems, the answer to number 8 is going to be x is equal to plus or minus 2I. The answer to number 10 is x is equal to plus or minus 2I square root of 3. And the answer to number 12 is x is equal to plus or minus 3I square root of 3. Right. Now, there are also homework problems that go along with this. So while you still have this screen up, go ahead and keep it up and use it as a guide for solving homework problems 15 through 21. So go ahead and get those knocked out, and then unpause the screen, and we'll continue on with the notes. Okay, so if you turn to the second page of your notes, there's a section titled Powers of I. So let's go ahead and complete that first little chart we have there. So we know that I to the first, which is just I, is equal to the square root of negative 1. Now I squared, what is that going to be equal to? That's going to be equal to negative 1, because I squared is just equal to I times I, and I is equal to the square root of negative 1, so the square root of a number times the square root of that same number is equal to that number. And what do you guys think I to the third power is going to be? It's actually going to be negative square root of negative 1. For I to the third power is equal to I to the first times I to the second, and those are square root of negative 1 and negative 1 respectively. So when you multiply those together, you get the square root, the negative square root of negative 1. All right, and I to the fourth, what do you guys think that one's going to be? Remember, I to the fourth is just going to be I to the second times I to the second, and I to the second is negative 1, so negative 1 times negative 1 is equal to 1. Right. Now, what's interesting is that from here on out, we don't really learn anything new. I to the fifth is going to be equal to I to the first power. I to the sixth is going to be equal to I to the second power. I to the seventh is going to be equal to I to the third power. And I to the eighth is going to be equal to I to the fourth power. In other words, the exponents of I just keep cycling through these same four numbers. All right, so I to the ninth, for example, will also be equal to I to the first power. I to the 12th will also be equal to I to the fourth power. So with that known, let's go ahead and work on that notes example problem 13, where we're asked to simplify I to the 15th power. Now I to the 15th is just going to be equal to I to the 12th times I to the 3rd. Now I to the 12th is divisible by 4, so we know that I to the 12th is going to be equal to 1. I to the 3rd we know is equal to negative square root of negative 1. Right. So what is I to the 15th? It's just equal to negative square root of negative 1. Let's look at problem number 4, example problem 14 as well. I to the 62nd power. Again, I always encourage you to pause it and try and answer it for yourself before I go ahead and answer it. Right, but here are the steps to answering this one. We know that 4 times 15 is equal to 60. And so that means that we know that I to the 62nd power is going to be equal to I to the 60th power times I to the 2nd power. And we know that because 60 is divisible by 4, that I to the 60th power is just going to be equal to 1. So, and we know that I to the 2nd is equal to negative 1. So I to the 62nd power is 1 times negative 1. And so that means it's just equal to negative 1. So go ahead and keep these notes page up and use them to help you solve homework problems 9 through 10. And then come back and we'll move on to the next section. All right, moving on to the next section, we're now looking at the final notes component, the products of pure imaginary numbers. All right, so here we don't really need to learn anything new. I'm just going to demonstrate how to use some of the concepts that we've already learned to answer some of these example problems. So 15, it is asking us to find the product of 4i times 7i. Right. Now that's going to be the same as 28 times I squared. What's I squared? I squared is negative 1. We learned that when going over the powers of I. So the ultimate answer to 15 is just negative 28. Okay, let's similarly look at 17. So we have 2i cubed times 5i. Now 2i cubed, what is that? That's 2i times 2i times 2i. 2 times 2 times 2 is equal to 8. And I times I times I is just I cubed. So we have 8i cubed times 5i. And so that's just going to be 40 times I to the 4th power. Now what is I to the 4th power? We know from our powers of I that that's equal to 1. So the product here is just going to be 40. Let's look at least another one here, 19. It's asking for the square root of negative 18 times the square root of negative 10. Go ahead and, as always, pause this, see if you can figure it out before I answer it. Right, so these steps that we would use to answer this, first we know that the square root of negative 18 is obviously the same thing as the square root of negative 1 times 18. All right, and likewise with square root of negative 10. And from that general rule I went over at the very beginning of this presentation, all right, we know that we can then break those two radicals up into these 4 radicals. Now, what's square root of negative 1? That's just I, so we're going to have I squared times the square root of 180. Now, 180 is equal to 9 times 20, and so we can similarly go ahead and break up that square root into I squared times the square root of 9 times the square root of 4 times 5. Right? 4 times 5 is 20. That was the part that was left over. Now let's go ahead and break up that final radical because we have another perfect square in there. All right, so this is ultimately going to be equal to I squared times the square root of 9 times the square root of 4 times the square root of 5. We know that I squared is -1, square root of 9 is 3, square root of 4 is 2, and we can't simplify the square root of 5. So our answer here is going to be -6 times the square root of 5. I'm going to go ahead and give you guys answers to the other 3 example problems here. So for 16, it's going to be, actually hold on, let me give you guys the homework first. All right, so see if you can use these notes to solve homework problems 11 through 14. I'm going to go ahead and give you guys the example answers right now. So the answer to example problem 16 is -72i. The answer to example problem 18 is 192. And the answer to example problem 20 is -12i. All right. Now the last thing I want to do is just go over homework problems 21 through 24. So here I have 21 up. We have plus or minus 4i. We're asked to consider this to be roots of a quadratic equation. So one of the roots is positive 4i. The other root is negative 4i. Now remember, the roots of an equation are the values of x at which y is equal to 0. Right, so now we need to try and write an equation that could represent the graph that has roots of, in this case, positive 4i and negative 4i. Now this is going to sound, this probably sounds a little complex and difficult, but it's really not. It's really quite simple. So when we're dealing with quadratic equations, remember we always have an x to the second power. And plus 4i, that's our x value. Remember, that's our x value for when y is equal to 0. That's what a root is. So we know that x is equal to plus 4i and negative 4i. Now x squared is going to be equal to 4 squared times I squared, which is just 16 times -1 or -16. So we now, if we move that to the other side, we get x squared plus 16 is equal to 0, and that's the answer. That's the equation. We could also think of that as being x squared plus 16 is equal to. I'm just going to leave it at that. I don't want to say anymore. But all right, if there is some equation where x squared plus 16 is equal to 0, then the roots of that equation is going to be plus or minus 4i. And you use the exact same procedure to solve the other homework problems 22 through 24. So please go ahead and solve those as well.